So in day 8, we're going to look at something called an explicit formula. A recursive formula requires that you know the previous term in order to find the next term. So here's an example again of a recursive formula. The first term is 54. To find any term, we take the term before it and I wrote this wrong, so let's switch this. To find any term, we take the term before it and we're going to subtract 2. So this would be if I asked you arithmetic or geometric, you'd say, hey, we're subtracting 2 every time. So this is arithmetic, which means the common difference is -2. So then it says find the fourth term. So we would do 54. We would subtract 2, 52, subtract 2, 50, subtract 2, 48. So we would say the fourth term is 48. This might not take too long to do, but is there a faster way where we can just plug in 14? Okay, so it says using the same sequence above, can you find the 14th term? And again, we can do that on our calculator. It doesn't take too long, but is there a more efficient way to just plug in a 14? How can we just plug in a 14 and what we come up with will spit out the answer? Instead of doing it recursively, we can do it a different way. So to start, is this sequence linear, exponential, or one of the other functions we've looked at this year? Now we know for subtracting 2 every time that is a slope. And we know if there's a slope here, this is linear. And if it's linear, we've looked at the equation y equals mx plus b. And so if you recall, m, the number next to the x, is your slope. And so here slope would be our common difference. Common D, common difference. And B is the y-intercept, and the y-intercept is at time 0 or term 0. So let's write an equation that we can use for the first one. Okay, so if we take a look at it, we know the slope is -2 because it's going down by 2 every time. So I can write y equals -2x. And then we need a y-intercept. The y-intercept is term 0, but we have the first term. The first term is 54, so we need to go backwards 1. Now recall, as we go forward, we are subtracting 2 every time to get to the next term. So if we want to go backwards 1, we're going to, instead of subtract 2, we will add 2. And so if there was a 0 term in this list, it would be 56. So let's take a look at that. I will put plus 56 here. And now we have something called an explicit equation. In explicit equation, we can just plug the 14 in and figure out what would be the 14th number in this list. So -2 times 14 plus 56 would give us the 14th number in the list. Instead of hitting enter 14 times, this would give us our number. And that number would be 28. So we could say a sub 14, I'll write it over here, equals 28. Okay, so 2 ways to get this number now. You can put it in your list and hit enter 13 times because you have the first term, or you can type it in your calculator if you know the slope and the y-intercept, and you can figure out using the explicit formula. So an explicit formula allows you to directly find any term without knowing the previous term. So here's another example, and then we'll take a look at a few more. Okay. A stadium with, okay, so this is the one that we looked at before. A stadium with 75 rows has 10 seats in the first row, 15 in the second, and I should have said 20 in the third, and so on. So this one would be arithmetic. Can you write a recursive formula for the number of seats? Oh, we did this before, so we would say in row 1 there's 10 seats. For any row, take the row before it and add 5. Can you write the explicit formula? We need slope and y-intercept. So our slope is right here. It's adding 5 every time. Our y-intercept would be like the a to the 0 term. You have to go backwards. So instead of adding 5, we'll subtract 5. So if there was a row 0, it would have 5 seats in it. Can you find a sub 6 and explain what it means in terms of, okay, so again, we did this yesterday, or not yesterday, but we did it before. So to find a sub 6, we could just plug in 5 times 6 plus 5 using the explicit formula right here. And so in the 6th row, there would be 35 seats. Or you can program your calculator and just hit enter every time like we did recursively. And again, which row has 50 seats? So we could put a 50 in right here, equals 5x plus 5, and we could subtract. And again, we have done this problem before, so if you recall, we solve for this, row 9. So x equals 9, so we could say a sub 9 has 50 seats, row 9. Row 9. Okay, so now let's take a look at a different type of sequence. So right here, I'm going to erase this right here. Okay, so different sequence. Is it arithmetic or geometric? So again, you can take any term and subtract the one before it. So 9 minus 5, we get 4. 13 minus 9, we get 4. All right, so this appears to be arithmetic. The recursive formula, we need a starting value. And then the rule, to find any term, we take the term before it and add 4. But now here's the new part. What's the explicit formula? We need slope. So y equals 4. And we need a y-intercept, which would go backwards 1. So instead of adding 4, we'll subtract 4. So 5 minus 4 is 1. Okay, so there's the explicit formula. Now we can use that to find the 14th term by plugging in the 14 for x. Okay, so let's do that. 57. So we would say, all right, in the 14th term would be 57. Or you can program your calculator and hit enter 13 times. Which term is 101? So we have 101 equals 4x plus 1. We could also stick an n. I mean, I really should be putting an n here for term number, but x is fine. All right, we'll subtract 1. We get 100 equals 4n. Divide by 4. So n equals 25. So the 25th term would have a value of 101. Okay. Let's take a look at example 3 here, arithmetic or geometric. And this one would be geometric. And the reason is if you take any number and divide by the number before it, you'll get 3 for any of these terms. So to write the recursive formula, the starting value is 1. To find any term, take the term before it and multiply by 3. All right, write the explicit formula. So if you've noticed, if we're multiplying by 3 every time, if you recall from chapter 5, this is exponential. And if it's exponential, we have it in this form y equals a times b to the x, where a is your starting value. Okay, start at times 0. And b is your common ratio. Okay, so if we write that equation, I'll squeeze it in over here. We'd have y equals. Okay, so what would be the starting value here? And if we're starting at 1, this is our first term. So the 0 term, instead of starting at 1, we would divide by 3. And so here, our starting term is 1/3. And then our growth rate, like whatever is it being, our common ratio is 3. And then we'll do to the x or to the n power. Okay, so that's review from exponential growth rate. We can test it. So we know the first term is 1. So let's check that and see if that works. So we have y equals 1/3 times 3 to the first power. And if we type that in, we get a 1. And that's what we started with right here. First term is 1. So now let's use this to find the 8th term. So we'll put an 8 in right here. And I'm going to type that in our calculator. Okay, so I'll use parentheses, or you can use the fraction key. So 1/3 times 3 to the power of 8. And so our 8th term would be 2,187. Or in your calculator, you can program your calculator to do it recursively. Which term is 177,147? Okay, so this one, sorry, I forgot to show you. Okay, so here's the next one. Which term is this right here? And we can use guess and check to solve. If you recall from when we did exponential growth and decay, we could guess and check whenever x was the exponent, but we could also use a log to solve. So let's do that. Let's divide each side by 1/3, which is the same as multiplying the left side by 3, multiplying by the reciprocal. So let's do that. So we have 177, 147, and then divided by 1/3, or multiply by 3, same thing. Okay, so we get this big number, and that equals 3 to the x. So I'm going to write that down. Okay, so let's put it over here. 531,441 equals 3 to the x. Okay, and now we're going to log it. So we have log base 3 of this, I'll put a and s, it's our last answer, equals x, and then you can type that into your calculator. So again, last answer is just this right here, 531,441. When we type it in, use your log key, base is 3 of our answer, so control negative, and that will type this 531,441 in for us, and the answer is 12. So x equals 12. Again, you could have just programmed your calculator and counted, but you can also use a log to solve. Okay, just a few more examples. Suppose you drop a tennis ball from a height of 15 feet. After the ball hits the floor, it rebounds to 85% of its previous height. How high will the ball rebound after its third bounce? All right, so if you take a look at this, it's multiplying by 0.85 every time, and so that is geometric with a common ratio of 0.85. So the recursive formula, we start with a rebound height of 15, and for every rebound after that, you take the previous rebound and you take 85% of the previous rebound, and you can use that and program that and figure out the third bounce. You would just type that in. We can also write the explicit formula. Okay, so we have our starting value is 15. Oh, explicit formula is this, y equals a times b to the x. All right, we need what was the height at time 0. So if we're making our list, I'm going to type this in so you can see what this looks like. So we'll start with 15, enter, and we're going to take our previous answer, multiply by 0.85. Okay, so there it is by the third bounce is at 10.8375. Okay, so I'm going to write this down. All right, so here's our list of numbers. Remember, to get every number, we multiply the previous one by 0.85. And so if I do want the 0 term, I have to go opposite and I have to divide by 0.85. So that's what we need to find the a value right here. Okay, so let's type that in. 15 divided by 0.85. Okay, so there's the 0 term, 17.6471. Okay, so I'm going to write that here. And then it's being multiplied by 0.85 every time. All right, so there's the explicit formula. So to find the fourth term, we would just type in or you can program your calculator to do it. Either way is fine. All right, so I'm going to take that times 0.85 to the fourth power. Okay, so by the fourth rebound, it has a height of about 9.21. Okay, which term is 12? So what that means is 12 equals 17.4601, 0.85 to the x. You could guess and check this. Let's log it. Let's divide each side by this. Okay. 12 divided by 17.6471. I wrote it wrong. Okay, 6471.6. Okay, so it should have been 0.6471. All right, I'm just fixing. I didn't write the right number. So I just changed my answer. All right, so we'll divide that first. And I'll leave that in there, but I'll write it down here. So 0.67998 equals 0.85 to the x. Okay, so here's what we came up with. This right here. Now we're going to log it. So log base 0.85 of this, I'll put just our last answer, equals x. And that's what we'll type into our calculator. So log of our answer. Oh no, we don't want our answer there. We want 0.85 here. Here we want our answer. So I'm just typing in what we have right there. Enter. And we get 2.37. So after on that bounce, after the second bounce, it'll be about 12 feet. Okay, so today we'll practice using the explicit formulas to solve, and we'll review that also in the coming days.